Today, I'm going to talk about how would you do these organic conversions a very easy way. Actually, I guess you guys already started doing these organic chemistry for 2026 endeavors. And when you are starting conversions, then only you are understanding the lesson is difficult. Actually, the lesson is not difficult. Going from one by one of these groups, number of reactions are involving become increasingly high, then the problem is then you forget. You keep forget what are these reactions. For that, you can make these smaller spider diagrams so you can memorize them. Actually, the whole organic note you can divide into three different parts. Those are organic reactions for conversions, and then the mechanisms, and then the last part is the identification test. If you know all these three parts, organic is extremely easier to get this practice. To get this talent, you have to practice with organic conversions. Okay, I'm going to go with this one of the very simplest organic conversion that you guys would do. The very first days of your organic conversion life, the one I have chosen is this. A little conversion that we are converting this primary alcohol, this is a primary alcohol, CH3, CH2, CH2OH, to this secondary alcohol, CH3, CHOS, CH3. There are two ways that you guys can do organic conversions. One way is just going from the reactant all the way to product. And the other way, analyzing the product, you can come back to reactant one by one step backward. Then once you feel like you are comfortable, again you can go with front to back. Likewise, I'll show you the both ways, but anyway, I'm going to start with the first part. Anyway, so to get the answer for this one, I'm using this little spider diagram. In there, this actually is my alkene box. All the reactions I have done here, it's in this alkene box. So let's say you have not done these alcohols, you have only the knowledge up to alkenes. Then again, this is still very easier. Okay, here initially they had OH in this compound, but finally the OH is in another carbon. So this carbon, if I number these carbons, I can number them as carbon number 1, 2 and 3. Let's say I number them as 1, 2 and 3. Again the same way, 1, 2 and 3. So here OH group is in the first carbon, carbon number 1. And here OH group is in the second carbon, carbon number 2. So I don't want this OH in my first carbon. So I will need to remove this OH. So I'm going to find a reaction to remove OH. How will you do that? Here I have it. See this one. In this one, if you go through this reaction, and here, when you add conceptual sulfur heat up to 170 degrees Celsius, you are removing OH, then you are making alkene. Here I'm trying to find a way to remove the OH from this first carbon. So that I'm going to make this double bonded alkene. Okay, see, I'm going to do that little step here. I'm going to do that little step here. So what would I do is, I'm going to add, let's say, I'm going to add here conc H2SO4 and then heat to conc H2SO4 and heating to 170 degrees Celsius. Conc H2SO4 heating to 170 degrees Celsius. This OH gets away with one of the hydrogen of this first second carbon. This OH belongs to the first carbon. This CH2 is the second carbon. One of the hydrogen of the second carbon is getting away from this OH of the first carbon. So the third carbon is not changing. I'm just writing the third carbon here. Third carbon just existing as same CH3. It is not changing. And then the second carbon, one of the hydrogen is getting away, so that's become CH. It is not CH2 anymore. I have only the CH. And then you are making the double bond with the carbon number 1. Carbon number 1 having CH2, but the OH group is not getting away. So if you write the byproduct, you don't want the byproduct for conversions, but if you write the byproduct here become H2O. So this is the middle compound. Then, is there any straight way that I can make the secondary alcohol from this given alkene? So I am in the alkene box. Okay, this is the alkene. Let's say I have all the reactions alkenes are doing. I'm going to find out wherever is there any possibility that I can see one OH group joins here, one OH group joins here. Yeah, I found it with del H2SO4. So what happens is if I add del H2SO4 and that is this reaction to alkane, if I add del H2SO4, double bond is breaking, addition reaction, hydrogen is joined to one side, Markovnikov, where the hydrogen is high, then OH joining to the other side. So if you go with this given molecule, the middle hydrogen is the one which is having less hydrogen, and the terminal hydrogen is the one having more hydrogen. So hydrogen goes to the hydrogen is high. So then the OH group is joining here. So if I draw this one here, let's say all the way, I'm moving from here to here. Let's say all the way I'm moving from here to here. Now I'm writing here the end product actually. So that's supposed to be this CH3 then CH, then CH3 and the middle OH. Isn't this one? So this one and this one is the same. So understood. Conversions are that easy. That's the first method. Going from reactant all the way product, I can do this one. Or I'm going to go through the other way around. Let's see that I have this initial compound and the final compound. So I'm going to start from this final compound to get to initial compound. What is our final compound? The final compound they were given is this secondary alcohol. You have this secondary alcohol here. So the second carbon having the OH here. But in the second carbon you don't have OH here. So first thing is I'm going to remove this OH. I'm going to remove this OH. To remove the OH, I'm supposed to add what? To remove the to get the OH. Sorry, to get the OH. So you don't have this OH in this first carbon, you have OH in the second carbon. So I need to join an OH here. So what is the way to join OH? To join the OH, there are supposed to be a double bond ahead of that. So I have to start from the double bond. So that's my alkene box again. From this alkene box, how would I join OH? So this is the way I can join OH. So again, I am writing, how would I join this OH here? I am joining this OH here by adding del H2SO4 to what? Del H2SO4 to this compound. CH3, CH, double bond, CH2. Okay, this OH and this hydrogen getting away, this OH with this hydrogen getting away. So from here, so you have double bond here. So now you know, to this double bond, according to Markovnikov rule, hydrogen gets to where hydrogen is high. And the other side you are getting the OH, so you are going here. Okay, what is the way? All the way from here to here you are getting. From here to here. How would you do that? All the way from our initial, this compound, going to all the way from this compound to this one. Making the double bond, losing this OH, that is the formation of alkene. So I'm going to go through somewhere here. These are the formation reactions of alkenes. Formation reactions of alkenes are here. So I'm going to find a path that I can make the alkene from alcohol. So it's obviously this one. Having the alcohol, concatenation of 170, you are making the alkene. So what I can do is, all the way from here to here, all the way from here to here, I'm just writing here, concatenation of 4 and 170. Conceptual 170. Okay, so this is one of the very simplest conversion you guys would do. If I give you guys the exact conversion here, okay, so they are giving this kind of a little conversion. Here you have 3 carbon alcohol, 3 carbon alcohol, and initially 3 carbon alcohol. I can't find my, oh, it's here. 3 carbon alcohol here. If you give this, if you number this, you have carbon number 1, 2, 3. Okay, so they have given the compound. Now I'm trying to analyze the initial and final compound. So this is a primary alcohol. This is a primary alcohol. Moving to the other side, I'm numbering 1, 2 and 3. So you guys can see this is the secondary alcohol. So they want us to convert this terminal alcohol to middle alcohol. So I don't want this OH in this first carbon. So I'm going to remove OH by adding H2SO4 170. What happened here is this one of this hydrogen in this carbon is getting away with this OH here. So you are making water molecule away. Instead of that, you are making a double bond here. Okay, instead of removing this water bond, you are making this double bond here. Now you are here. Now I want to add an OH again. What would I do? I'm adding either the H2SO4 170 or otherwise you can add H2SO4 and water. What happened here again is to the carbon, green one, which is having more hydrogen, going to Markovnikov, another hydrogen is joining. To the carbon, which is having, see another hydrogen is joining. To the carbon, let me go with the yellow. This carbon having less hydrogen now joining with OH group. Joining with OH group. Okay, so that at the end of the day, so you are coming here. Let me delete this part. You are coming here. So this you have OH here. So that OH is this one. And then this green hydrogen is one of the hydrogen here. So you already have 2 hydrogen, another hydrogen is joining. So that all these become 3 hydrogen. So then you are making CH3 or CHOH, CH3. Okay, so this is the conversion. Here I was explaining one of the simplest conversion for a very first beginner who just done the advanced level organic chemistry. Just to convince you, organic conversions are not difficult. It's you just need the consistent practice, plus you need this kind of a some sort of this short note system that you guys can see all your conversions in one single place, or all your reactions in one single place, so you can go through them, understand them and refer them to get these final conversion answers. Okay, to do conversions you guys need some sort of a summarize reactions together that you can refer continuously. So you have 2 methods to do conversion, starting from the initial compound to the end, or the going going from the back to initial, analyzing the last compound and then adding these middle compounds to that. Okay, back and forth you can go to both sides to get these answers. Organic chemistry is really important for final exam. Usually you would get around like 20 to 20-ish percentage of marks for organic chemistry. If you practice well, organic conversions are extremely easy.